Hi, this is John again, and I'm going to be going over Charles P. Mckeague's Chapter 1 review test, actually, from Section 4. And I decided to just do the even ones to help you guys, and if you can do the odd ones, that would be great. Now, first of all, I have x plus 2. It's a right triangle, of course. Here it is, located. X plus 2 is equal to x on the hypotenuse, and the x on the one of the legs, and 4 on one of the sides, and I want to try to find what the value of x is. So what I'm going to do first is I'm going to use the stacking theorem on this one. X squared plus 4 squared is equal to x plus 2 quantity squared. And I'm going to use a different pen because my ink is running out a little bit. X squared plus 16 is equal to x plus 2 quantity squared is going to be x plus 2 times x plus 2, guys. So don't forget, you have to FOIL this out. That's a common mistake. You go x squared plus 4, that's actually absolutely wrong. So it's going to be x squared plus 4x, 2x plus 2x is 4x, plus 4. Notice that the x squares cancel. You subtract x squares to both sides. Subtract 4. 12 is equal to 4x, and x is equal to 3. And here we found out x, it's going to be 3. The sides are going to be 3, and then 4, and then 3 plus 2 is 5. Oh, it's a Pythagorean triple. Don't forget that, guys, okay? You have another triangle, number 4, a 45, 45, 90, 30, 60, 90. Find x, h, s, r, if y equals 3. So y value is 3 right there. Of course, on the 30, 60, 90, this is twice the length, so x is equal to 6. That's one of your answers. H is going to be multiplied by root 3, so h is equal to 3 radical 3. From here, we know that it's a 45, 45, 90. The value of s is equal to, since this is a leg of a 45, 45, 90 triangle, we know that s is going to equal 3 root 3 as well. And r, to find r, to go from the leg to the hypotenuse, you multiply by root 2, so it's 3 root 3 times root 2. Root 3 times root 2 is root 6, so the radius, r, not the radius, the r value is going to be 3 radical 6. Oh, there you have it. And so you found out all of them. Okay. Number 6. It says, how many degrees does an hour hand turn in 5 hours? I changed the problem a little bit so that, you know, it's pretty simple if you do the 3-hour hand. So let's say here's a clock right here. That's 12, that's 6, that's 3. 1, 2, 3, 4, 5. So from here to here, that's how much the hour hand moves. I want to try to find how many degrees that moves. Well, we know that from 12 to 3, or from 3 to 6, it's going to move a total of 90 degrees. So each hour is going to move 30 degrees. So 30, 60, 90, 120, 150. That's how much the hour hand moves, and 150 degrees. Graph 2x plus 3y equals 12. I made it just a little bit different. This is in standard form. This is problem number 8. This is in standard form. There's a quick graph for this. You do not have to change it into slope-intercept form. So when x equals 0, when you plug in 0 for your x, there it is right there, and your y value is going to be 4. When y equals 0, plug in 0 for there, x is equal to 2x equals 12, x equals 6. So your coordinates are 0, 4, and 6, 0. 6, 0 is located here. 0, 4 is located here, and what you do is you just draw that line going through those 2 points. That's a quick way if it's a standard form instead of slope-intercept form. Okay, guys? Next problem. Number 10. Find the distance from the origin to a point x comma y. So we're looking for the distance right here. So let's find the distance. So the distance is equal to the square root of x2 minus x1 squared plus y2 minus y1 quantity squared. So using the distance formula, here we have it so far. Let me put this out just a little bit nicer. The distance is equal to square root of x2. We can call this x2, so it's going to be x right there. And then where's x1? We have a point. It's called the origin. The origin is 0, 0. So x minus 0, 0 squared plus y minus 0 quantity squared. That becomes square root of x minus 0 is x squared plus y squared. That's it. That's your answer right there. Nothing more to it. Find the sine, cosine, tangent for 90 degrees. 90 degrees, it terminates in quadrant 2 or 1 in between both. That's 0 degrees right there. Standard position, you're moving it up 90 degrees, so that's 90 degree position right here. Pick any point you want. Call it 0, 1. Don't call it 1, 0. 1, 0 is located right here, guys. Okay, so 0, 1 is a good one. X equals 0, y equals 0. The radius is equal to square root, y is 1. The radius is equal to square root of, what was the formula that they used actually? A squared plus b, x squared plus y squared. So the radius is equal to square root of 0 squared plus 1 squared, which is 1. Square root of 1 is 1. So how do you find the sine of theta? If you recall, using x, y's, and r's, sine is y over r, opposite over hypotenuse. Cosine of the angle is equal to adjacent of hypotenuse, which is x over r, and the tangent of theta is equal to y over x. Armed with that information, sine of the angle, theta, is equal to y. Y is 1 over the radius is 1 is 1. Actually, I should say since the theta is 90 degrees right there, the sine of 90 is equal to 1. And the cosine of the angle, 90 degrees, is equal to x over r, 0 over 1, which is 0. And the tangent of the angle, tangent of 90, is y over x, where is y? Over 0. 1 over 0, that's undefined. Remember, division by 0 is never, ever, ever allowed. Show you my calculator how that works too. Turn it on first. I don't know if you can see this or not. So what we're going to do here is we're going to say, make sure you're in the right mode. It should be in degrees right there. So if you're in the wrong mode, you can't get the correct answer. The sine of 90, obviously, is going to be 1. The cosine of 90 degrees is going to be obviously 0. And the tangent of 90, there's a tangent button right there. Tangent of 90 is going to be undefined. Domain error, basically. Okay? So there we have it. I don't know if you guys can see it better or not, but here it is. Okay? 12. Next problem, number 14. Which quadrant will lie? I want to find the quadrant will lie if sine of theta is less than 0 and the tangent of theta is less than 0. Sine of theta less than 0 means y over r. Less than 0 means it's going to be a negative number. We know that the radius is always positive. We're looking for the value of y that makes it negative. The sine is negative. The y value is negative in quadrant 3, 4. And let's look at the tangent of that angle. I changed the problem just a little bit. I made it just a little bit harder for you guys, okay? But it's the same concept every single time. Tangent of the angle is y over x. When it's one of them positive, one of them negative. This is negative, this is positive, This is positive, the x value is negative. So one of them has to be positive, one of them has to be negative, and if you think about that, really put a little bit of thought process, it's going to be quadrant 2 and quadrant 4. So where do they both lie? It's going to be in quadrant 4. I'm sure he'll give you something like this on a test with sines or cosines or tangents, whatever. Okay. Number 16, find all trigonometric functions for theta given the points lie the terminal side of theta with negative 3, 5. So I used a different number. You can use any number you want and try to figure it out. So that's my x. I'm going to label it x. I'm going to call this, label it y. And we have to first find the value of r. R equals square root of negative 3 squared plus negative 5 20 squared. Don't forget, the formula is given by r equals square root of x squared plus y squared. So the radius is equal to square root of 9 plus 25 square root of 34. Don't forget, if you look at it, it's not the 3, 4, 5, it's 3, 5, and the square root of 34. So maybe a little bit tricky on you guys. Same type of problem as number 16, the original problem. So we're going to find sine of theta. Sine of that angle is going to be y over r. Y is negative 5 over root 34. Cosine of the angle is equal to x over x direction, the adjacent, over the hypotenuse, which is going to be negative 3 over root 34. The tangent of the angle is equal to opposite over adjacent, y over x. Opposite side is going to be negative 5 over negative 3, which is 5/3. Don't forget, this is in quadrant 3, guys, so the tangent does have to come out positive. Okay, that should be helpful for this one right here too. The reciprocal of the sine function is going to be this cosecant function. Cosecant function, instead of y over r, it's the reciprocal, r over y. Just flip this around, root 34 over 5, negative in front. And the secant of the angle is the reciprocal of the cosine. We just flip this, negative root 34 over 3. And the cotangent of that angle is equal to y. The tangent, remember, was y over x. It's in the x over y. Flip this around, 3 over 5. Okay. Next problem, number 18. I have about 10 minutes left. I'm going to try to get this done as soon as possible. Okay. The sine of the angle is 1 over 5, and theta, sine of that angle theta is in quadrant 2. Find all functions. Find all trigonometric functions, that is. So how do we do this? That's your, since the sine is y, r, we have to find the value of x. So r squared is equal to x squared plus y squared. Don't forget, this form right here, r equals square root of x squared plus y squared, is the same as this. I just took the square root